What I want to do with you now, kind of having these formulas available to us, is work on an actual free response. Okay, this is from the 2018 exam. So life was normal. There was no pandemic. We took this exam in person. And this was a calculator-based question. Okay, you'll see how much we use the calculator here to do this problem. So you can see we've got a particle moving along the x-axis. So that just means when we think about, it's kind of like the b, it's just moving back and forth along this axis, right? And then we've got a velocity function, which is much like what we had with the b. The b problem we did graphically. So this problem we're going to do it algebraically. Okay, and our calculations only fit the description between 0 and 3.5. Okay, they also tell us the position at time 0. Right, that's how I would interpret that. It is very difficult for students when you see x equals -5. It's hard for you to remember that that is very much like the y value of this problem, because time is the input. Right, and x being equal to -5 just means it's moving along the x-axis. All right, so that's how you can kind of think of that. So for part A, find the acceleration of the particle at time 3. We are just going to show our work and then use the calculator to provide the answer to the judges, right? So part A here says find the acceleration. We are going to say, ooh, we're not saying anything yet. Okay. Acceleration at time 3 is equivalent to the velocity's derivative at time 3. That's all you have to write down. And then you go to the calculator and use Math 8, right? So if you go to Math 8 and you fill in all the blanks, you are going to get -2.118. I actually want to point out to you a way to use y1 in this problem. So when you have a free response like this, it makes the most sense in the world to hit the y equals button and input this function in y1, because you're going to recall it time and time again for this problem. So having it stuck in y1 means you don't have to retype it every single time you ask the calculator to do something with it. You just put it in one time and then call upon the y1 variable to make your calculations. So I want to remind you about where y1 is. So if you were to use Math 8 in part A, it's going to look like this in the calculator and then I want you to enter y1 here once you get that function in there. And then in this box is where you put 3. So the way that you get that y1 is to hit the math button. We've done this a couple times before, but we'll be using it a lot more now. Go over, no, sorry, not math. The vars button, sorry, bad instruction, which is next to clear. Arrow over to y vars, and then you see the hit enter on function. And then the first choice there is y1. So it's vars, y vars, and then function number 1. Option 1. All right, let's move on. Part A didn't ask for any units, so this work is all you need to write down, and that's probably worth 2 points on the AP test. Part B, find the position of the particle at time 3. So here's our chance to apply what we've been learning right now. They're asking us for a position. I kind of think of this like in the future compared to the position they gave us in the problem in the original, time 0. So if we go back to these two position formulas at the bottom of the top page, if we're being asked to find the position of the particle at time 3, right, that's at a time after the given moment, that's the pink formula on top. So we are just going to do, right, actually, let's use position. Let's use x for position. X of 3 is equal to, we don't have to write x of 0, but that's what we mean. So we just put in the -5 plus the integral from 0 to 3 of velocity. And then again, you don't have to write the function in the integrand space. You can just use v of t because that's what they named it. Then you type all that into your calculator, which we've been practicing, and you should get negative 1.76. Okay, again, this negative 5 bleep, 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 comes from up here. Probably should have called that x of 0. So that's how we made use of the given information. Okay. Part C says to evaluate two different integrals. One is the integral from 0 to 3.5 of v of t dt, and one is 0 to 3.5 of the absolute value. Interpret the meaning of each integral in the context of the problem. So for part C here, I'm going to put our work down below. I'm just very clearly organizing my work so the judges can see it. So I'm going to put this integral here, and then I'm going to put this integral here. There should be no confusion about where your answers for each integral are. Okay, so you're just going to do math 9 for the top one. Okay, type that in. Use the y1 notation from your calculator. Don't write y1 on this for your response, but just call it v here, but use y1. And when you hit enter, you should get this. Okay, and we would say, all we have to state is this is the displacement of the particle. And then we have to cite the limits, right? Over t equals 0 to t equals 3.5. Okay, so that is giving context, right? We're talking about how far it is from where it started. Okay, the second one, right? Remember that we're going to use the absolute value feature, which is in the math menu. Go over to number. And then still use y1. And when you make this calculation, do it a couple times till you get it right, whatever it takes. You should get 3.737. And we would say this, because of the absolute value marks, is the total distance traveled by the particle from t, I mean, kind of same as the beginning of them, t equals 0 to t equals 3.5. Oh boy. To t equals 3.5. Okay, if you do not include these, you might as well kiss your answer goodbye. Those time limits are very important to address. They need to make sure you understand what those limits on the integral represent. Okay. And then the last one is part D. A second particle moves along the x-axis with position given by x of 2 of t equal to t squared minus t between 0 and 3.5. So at least it's the same interval. At what time are the two particles moving with the same velocity? So moving with the same velocity, that phrase just means their velocities are equal, right? Velocities are equal. Okay, and immediately as I'm thinking about this, I'm kind of regretting not doing this by a way that you can see my calculator screen. But let's give it a go. So we know the velocity of the first function is called v of t. We do have to determine the velocity of the second function by differentiating it. So the second function given to us as a position. So if we want v2, we need to differentiate that, which of course I didn't, which is 2t minus 1. And so that's the second particle's velocity function. So we want to set this equal to the original function they gave us. So what we have to do to score points from the judges, we first of all have to show where 2t minus 1 came from and use the proper notation. Second thing we have to show is an equation, right, set up that I'm going to solve. So 2t minus 1 set equal to the function they gave us, which again they named v of t, is the equation I'm going to solve. You could, of course, like write out to, an actual equation looking thing. But I just hate suggesting this because there's so much room for typos. Okay, I don't love this because this communicates the same thing and it's less work. Okay, so all you have to do is write the equation that you're trying to solve down, and then you can use the calculator to solve it. Okay, so you wouldn't show this work, but for the purpose of the notes, I have to tell you how to do it. So y1, right, is that function that they gave us. So that's v of t. And then what we're going to do in y2 is we are going to type in 2t minus 1. And then your job is to find the intersection. And again, you're only looking in 0 to 3.5. So you're going to need to manipulate your window a little bit to just see the x value 0 to 3.5. You could try a zoom trig window because there's sign in the original v function, and then manipulate your y-axis based on how much you see or if you see an intersection at all. So with that equation solved, all right, you just have to hit second trace, choose intersection, choice 5, and enter, enter, enter. And then you should get 1.570, and other acceptable answer if you rounded would be 1.571. Okay, so all of this work aggregately together on this problem